Let's talk about how we would solve systems of equations by substitution. And let me just remind you, I've made a previous video about doing this graphically, which is maybe the hardest to do because it's really difficult to sometimes see on the graph where things kind of are solved. But let me just remind you what this solving systems means. This means we are looking for an intersection point. Okay, we're looking for where two equations intersect each other. So that is an x and a y value. Okay, so we need to remember that we're finding a coordinate where things intersect. Now, the substitution, there are kind of two methods, two ways we can do this substitution. I'm going to go through both and kind of explain the use. I would say that there's a specific time to use substitution, and I'll kind of show you an example of each kind. So let's do one. So here we have two lines. We have the line y equals 5x, and we have the line y equals negative 4x plus 27. Again, you could solve this with graphing, but think about with a y-intercept here of 27 and some very steep slopes, this would be a lot to graph. It might be really hard to make an effective graph to see what's happening. It would be easier to solve this with another method. Now, I look at this and I think both of these equations, both of these things are y equals. And since we're trying to figure out where these things are the same, if both equations are y equal, why not just set them equal to each other? And the reason this is a substitution method is we're going to take like this 5x and substitute it in for this y. So we're going to say 5x is equal to negative 4x plus 27, like that. And then we're just going to solve. So I'm going to add 4x to both sides. I like to get all my x's together. I have 9x equals 27. Divide both sides by 9. And x is 3. We're not done. Remember, we need an x and a y. Now, we know what x is. Now, to get y, we can use either one of these equations, either one, and plug 3 in. It doesn't matter. I personally think that first one looks a lot easier. If I could just say, well, in my case, y is equal to 5 times 3, so that's 15. I think that's a heck of a lot easier than the other one, but certainly both will work. Remember, we're finding an intersection, so it's got to work in both equations. So if you did negative 4 times your x plus 27, that will also be 15. So in a case where both equations are y equals, we can just set them equal to each other, essentially substituting the equation in for y. And that's why we call it substitution. Let's do one more like this. So in this case, you can see my two equations are maybe a little bit bigger than the last ones. And again, this could be solved by graphing, but I think we can just say, well, if y is equal to this right here, why don't I just substitute that in for that y? So we can say that negative 3x plus 4, substituting that for y, is equal to 2x minus 1. And then we're going to solve like always. We're going to say subtract 2x from both sides. Maybe subtract 4 from both sides. So negative 3x minus 2x is negative 5x. And negative 1 minus 4 is negative 5. Divide both sides by negative 5. X is 1. Again, 1. But we need the other part, so we're going to plug it in. Again, which equation does not matter? Negative 3 times 1 is negative 3, plus 4 is 1. That is also then my y-coordinate. And let me just show you, if you plug that into the second one instead, which actually isn't a bad way to check your work to make sure that you got it right. It's the same, so the y is the same for both. So first method of substitution, you have two lines, y equals, set them equal to each other. If they're both equal to y, we can substitute. Let's do the other kind of substitution. So this kind of substitution works really well when you have one line written in what's called standard form, where the x's and y's are both on the same side of the equals sign. And the other is written in kind of our y equals, our slope-intercept form. And the easiest way to think about this is we're going to say, well, I have a y right here, and I can say, well, y is equal to 2x. I can substitute that in. And let me do that and then explain why that's so helpful. So I'd say negative 7x, just taking this equation down here, plus 5 times, and instead of y, I'm going to say 2x, since that's what y was equal to. The reason that's useful is now as I simplify a little bit, I'm down to one variable. Negative 7x plus 10x is 3x. Divide both sides by 3. X is negative 9. And in this case, again, I'll stand by the fact you can solve either one of these to get y, but boy, I think that this equation right here, the second one, is easier, because in this one, y is simply equal to 2 times x. So if I just do that and get negative 18, that's my y coordinate. That's a heck of a lot easier than the other one. So this second kind of substitution is where one of the lines is kind of in a standard form where the x's and y's are on the same side, and the other is written in that y equals form, and we could just eliminate a variable. Let's do one more like this that maybe is a little different. So once again, you can see I have one equation written in kind of this standard form where the x's and y's are on the same side of the equals. And then I have this other that's actually not a y equals, but rather an x equals. But we can use this as well because there's nothing saying we always have to substitute in for the same variable. If I know what x is equal to, I could replace it with this negative 3y. I could just put that in place of x. So let's do that. Let's write that. I've got negative 7, and instead of x, I'm going to write what x is equal to. So I've got 21y minus 2y equals negative 38. Well, 21y minus 2y is 19y. Divide both sides by 19, and that is negative 2. Now I got to be a little bit careful here because I solved for y. For the first time, I solved for y here. So that's negative 2. Well, to get x, again, I think that this equation would be the easiest way to go. X is equal to negative 3 times y. Well, that's 6. So that would be my x coordinate. So again, we have two types of substitution. If we have two y equals equations, we just set them equal to each other. Solve. Don't forget to solve for both x and y. And the other type is where one of our equations is in standard form, like this, and the other is written as maybe one variable equals some kind of function of the other, and then we can substitute in that way. If this video helped you, please like and subscribe for more math help.